Hello, everybody. This is Dr. Looney. Hopefully, all is well. Um, I'm going to start uploading videos at least once a week over the material that we're going to be covering. Hopefully, everybody has already received the notification through Canvas. But today, we're going to talk about the area of a regular polygon. So first, I just want to give you a brief description of what a regular polygon is. So it's a polygon that is equal angular, and so that just means that all the angles are equal in measure, and then it's also equilateral. So that just means all the sides have a same length. And one polygon that you should be already familiar with is going to be a square. So a square is a regular polygon. We know that all the sides of a square has equal length, and if you think about all the angles, they all have the same measure, and that measure is going to be 90 degrees. So a square is a regular polygon. And if you think about an equilateral triangle, we have all the sides of an equilateral triangle are going to be equal, and then all their angles should be 60 degrees. So all the angle measurements are equal. So an equilateral triangle is another example of what a regular polygon is. But what we want to focus on in this video, at the end, you should at least know how to find the area of any regular polygon. And so the smallest polygon that we have is going to be a triangle. It has 3 sides, and then we move to quadrilaterals, which has 4 sides, and so forth. So, but we want to be able to find the area of any size polygon. All right, so let's look here. This is a polygon. Sorry, this is the wrong page, but this is a polygon, which is a hexagon. A hexagon just means that it has 6 sides. And so we're going to use this hexagon to kind of come up with the definition or the formula to find the area of a regular polygon. So the first thing we want to talk about is the opposite. So the opposite is going to be your perpendicular distance, and so that's going to be this in green. And so, what does the opposite does? And so I did mention this earlier, but I should have mentioned this before I begin coming to the second page. But make sure you do stop the video and write down these definitions. And since it is a video, you can of course go back and replay it, but at least make sure you're just taking the time to pause the video and write down some of these definitions. All right, thank you. So back to the opposite. The opposite is going to be this perpendicular distance here. So if you look at this hexagon, you have H, which is going to be the center of this hexagon. And then if you look at this purple line, and I'll go into a little bit more detail, a little bit more later on, but these purple lines are going to be the radius of the hexagon. All right, and so what does the opposite do? It's going to bisect the central angle and the side. So if you see here, this is going to be your central angle here, because the vertex of this angle is at the center. And so this is your central angle, and so it's going to bisect this in half. And so, and it's going to also bisect the sides here. So that's why I have these 2 marks here. That just means that they have equal distance on each side of the opposite. So as I mentioned, it bisects the central angle. So if you want to determine what the central angle is for any polygon, then you're just going to take 360 and divide it by n, and where n represents the number of sides. So for this particular shape, we have a hexagon, which has 6 sides. So in this case, our n is equal to 6. So our central angle is going to be equal to 60 degrees because 360 divided by 6 is just going to be equal to 6. So that's how you determine what the central angle is. All right, so let's move on to determining what the area of this particular shape is going to be. So let's look here again. This is going to be, all hexagons are not regular polygons, but this hexagon, we're going to assume that it is a regular polygon. So that means all the sides are going to be equal. So that's why, and I'm just going to represent I'm going to use S to represent the length of the side. So this side has a length of S, so forth. This side has a length of S as well. And here, this is the center of your circle. So that means that this purple line would be your opposite. And then if you draw a line segment from the center to any one of these vertices, then that becomes your radius. And so you can do it again here. I can draw a radius here. I can also draw a radius here. I could draw a radius here. Then I can draw a radius here. So do you see that going from the center to the vertexes of the regular polygon, then we can create triangles. Now, since this is a 6-sided shape, I'm going to always be able to create 6 triangles. If it's a 7-sided shape, then I'm going to be able to create 7 triangles. And if it's 8, etc., then I should be able to get 8 triangles. So, well, if I wanted to find the area of the entire shape, I can find the area of just one of these triangles, because since it's a regular polygon, then all of these triangles are going to have the same area, and then I can just multiply it by 6. So I drew a little triangle over here to the side. And so if you can see here, the height of the triangle is going to always be the opposite. And so I have the letter A represent the opposite. And then, of course, if you can see here, the base of this triangle is just one of the sides of the hexagon. So that's why I labeled the base to be S. Now we know if we want to find the area of a triangle, that's just going to be 1/2 the base, right, which is my X, times the height, which is my A. So just the area of one of these triangles is just going to be 1/2 A. And again, I know it looks like a 5, but that's a S. So this is just the area of the triangle. So if I want to find the area of the hexagon, well, how many triangles do I have? I have 6 of them. So I need to take that area and multiply it by 6, and that should give me the area, the formula for the area of this hexagon, right? So again, if you can see here, this is my 1/2. I still have my A, and then I multiply my S by 6 because it is 6 sides. And so if I want to find the perimeter of the shape, I just have to keep adding the sides. So that's what the 6S is going to represent. It's going to represent the perimeter of the hexagon. So you can see that if I wanted to find the area of the hexagon, I could just take 1/2 the height, which is the opposite, and multiply to the perimeter of the shape. And so that should give me the area of the hexagon. And so here, that's how we come up with this little handy formula. If I want to find the area of any regular polygon, then I'm just going to take 1/2 the opposite, and then I'm going to multiply that by the perimeter of the shape. And so your perimeter is not always going to be 6S, because if it is a 7-sided shape, then it should be 7 times S. and you're going to have a value for S. So, and I'm going to give you an example in a minute, so you'll see exactly what I'm talking about. So let's now go to that example, because there's two things that you should be able to do by the end of this video. You're going to need to be able to determine what the central angle is of a regular polygon, and then you also need to be able to determine how to find the area of a regular polygon. So let's look at this example. So in this case, in this particular case, I have a pentagon. So a pentagon is a five-sided shape. So I know my n is going to be equal to 5. And since it's a regular pentagon, then if from A to E is going to be 8 centimeters, then that means from E to D is 8, D to C, and so forth. They're all going to be 8 centimeters. So the first thing I did was I went ahead and found out what the central angle is, because again, I said that is one thing that you're going to need to know how to do, and that central angle is going to be 360 divided by 5, which is 72. We divided by 5 because a pentagon is a five-sided shape. So that's one thing that we can check off, because you should be able to find the central angle. And then lastly, we're going to look at finding the area of the shape. So it's given that the optimum is going to be 5.5, and I know that may be a little bit difficult to see. So I know my A is equal to 5.5. Well, and now I just need to find P. Well, if one of the sides have a length of 8 centimeters, then to find the perimeter, I just need to multiply that by the number of sides, which is 5. So my perimeter is actually 40 centimeters. So now I have the area of the regular polygon, in this case, which is a pentagon, is going to be 1/2 the optimum, which is 5.5 times 40. So that's going to give me 110.11 centimeters squared. And so that would be the area of the pentagon. And this, remember, this is only for regular pentagons. Are all pentagons regular? No. So this is only the formula when we're trying to find the area of a regular polygon. So I'm going to post some problems that you will need to complete, that they will be on Canvas, and so as well as this video. So the problems is just going to ask you to determine two things. You're either going to be looking for the central angle, or you're going to be finding the area of the regular polygon. And so hopefully this video will help you out in achieving the goals that I've set forth for you. If you have any questions, you can email me and we will go from there. All right, have a good day, guys.